Alright, so this is a continuation of section 8.2. So this is 8.2 part 2. And what we're going to be working on now is we're going to be working on polar equations. So we are going to be going back and forth between Cartesian equations and polar equations using the same equations that we talked about before. So x equals r cosine theta and y equals r sine theta, and doing whatever substitutions we need to. When we go the other way, we're also going to be needing the x squared plus y squared equals r squared equations. So for this one, we have to rewrite the Cartesian equation x equals 3 as a polar equation. Now, it's really amazing to see what these equations look like when you go back and forth. Now, this one is just a line, but when we go into polar equations, and you're going to be graphing some of these on Desmos, they can really make some polar equations can make some really amazing, beautiful graphs. So for this one, all we have is the equation x equals 3. And so we're going to go in and we're going to substitute what we know for the polar equations in for x. So instead of writing x, I can write r cosine theta. And then that is equal to 3. So when we have a polar equation, we want to solve that polar equation for r. So we have the equation r cosine theta equals 3, and then solve that equation for r. So now we have r equals 3 over cosine theta. So for polar equations, very first thing that you want to do is any substitutions that you can using the equations that we've talked about before. Substitutions. Okay, then you want to simplify your equation. So this one we didn't have any simplifying to do, but we might have fractions and fractions within a fraction, or be able to simplify or get rid of parentheses, or lots of different things. And then the last step that you want to do is to solve for r. So polar equations should be solved for r. Cartesian equations will be solved for y. Right, moving on to example 4, we have rewrite the polar equation. So now we've got a polar equation, and we want to write it as a Cartesian equation. Okay, so let's first of all plug in for cosine of theta. And that's the first thing. You always want to substitute for r last on going from Cartesian to polar. So substitute for r last. So do all of the cosines and sines that you can, and then simplify. Okay, so we're going to simplify that. So go r equals 2. Now what was cosine theta equal to? We had x equals r cosine theta. So if we divide r from both sides, we would have cosine theta is equal to x over r. So now we have r equals 2x over r. And now notice I have a fraction. I'm going to get rid of this fraction so I can multiply both sides of the equation by r. And I got r squared equals 2x. Now let's go ahead and do that substitution for r. Because remember that we had r squared is equal to x squared plus y squared. And now we can do that a little bit easier and not have to worry about the square root. So we have x squared plus y squared equals 2x. And then the last step for this one will be to solve for y. Okay. A lot of times these end up being equations for a circle. And actually, let me pause and look at how, I'm pretty sure they always want you to solve for y, but let me pause and look real quick on my open math. Okay, so I'm glad I checked that, because they do leave this answer just like this, and they do not solve for y. So if you have anything that looks like it's in the form of a circle, leave it like that, because that's what we get a lot with these polar equations. Everything is circular. So something like that, that's the answer that they want on my open math. All right, so for example number 5, we've got rewrite the Cartesian equation y equals 6x squared as a polar equation. So we need to know what y is, we need to know what x is, and we're going to substitute both of those in at the same time. So we have x equals r cosine theta, and y equals r sine theta. So let's make that substitution. So now we have r sine theta is equal to 6 times, now we have to square everything with the x, so it's going to be an r squared and a cosine squared theta. And so now what we need to do is we need to solve for r. That's going to be our last step. Normally we don't like to divide by variables because we lose a solution, but these polar equations are cyclical, means they cycle through multiple times anyway. So we can go ahead and divide both sides by an r, and we won't lose any part of our equation. So now we have sine of theta is equal to 6r cosine, oops, that's an equal sign, cosine squared theta. And now I want to solve for r. So I'm going to divide both sides by 6 cosine squared theta. And over here by 6 cosine squared theta. And then we have our final solution is r is equal to sine of theta over 6, oops, not that, by 6 cosine squared of theta. And that's your final answer. Example number 6 wants us to write a polar equation for the graph here, written here. So polar equations, the r actually stands for the radius. So in this case we have a radius circled, centered at 0, 0, and its radius is 2. So that's all that we have to do for that. Now if we wanted to look at it in terms of Cartesian two polar coordinates, in Cartesian coordinates we would have the equations x squared plus y squared equals r squared, which in this case is 4. And then we have x squared plus y squared. If we wanted to change that into polar form, that would be equal to r squared. And then we still have the 4. Then you could take the square root of both sides and see that r equals 2. And then that would be the polar form, which we can tell just by looking at the graph. On example number 7, we have a little bit bigger of an equation that they're giving us. What I would like you to do first, I think it's easiest if you can get rid of any fractions first. So if you come up with one of these polar equations and there's a fraction in it like this, first thing that I would like you to do is get rid of the fraction. Okay, so number 1, we are going to multiply by both sides by the denominator. So get rid of fraction. Alright, so then we are going to have r times 5 sine theta plus 31 cosine theta. Now there's a couple of different ways we could do this. We could go ahead and do our substitution for sine and cosine right here, or we could also multiply that r through. I don't know that one way is easier than another, but I'm going to go ahead and multiply the r through the parentheses, and so we have 5r sine theta plus 31r cosine theta equals 2. And then what that gives me exactly my y and my x. So remember we have x equals r cosine theta and y equals r sine theta. So now we can go ahead and do that substitution here and here. And we have 5y plus 31x equals 2. And then they want us to write it in the form of y equals mx plus b. So just simplifying from here, we'll subtract 31 from both sides. 31x, we get 5y equals negative 31x plus 2. And then divide both sides by 5. Y equals negative 31x over 5 plus 2/5. And that's our final answer. Okay, so let's look really quick at the different kind of graphs that we get from all of these polar equations. So a very basic one is going to be our circle. We are not going to go into a lot of detail, especially this year where we don't have the time and we're not in the classroom. I'm just going to show you these. You guys are not going to be responsible for finding the names or anything like that. If you do have to graph anything, you will be able to use Desmos to compare the graphs. So any questions on tests or quizzes will be just like what you have on your homework, and you'll be able to use Desmos to go ahead and graph those and look at them. But I do want you guys to be aware of what there is. So we've got a circle. Okay. We also have a cardioid. Now this cardioid is a circle that comes in a little bit, kind of has a heart-shaped top to it. And then a limacon. A limacon kind of, it looks more like a lima bean. So depending on the graph or the equation for that, it can either have an opened inside circle or it can have more of a closed inside circle. So those are kind of like limacons. Think of them as a lima bean. A limnoscate is going to be more of a, can be this, well, figure 8 shape, I guess. And then this is going to be a rose, what we consider a rose. And there's lots of different things. I wish we kind of had more time to go into these. It really is interesting to see the relationship between the graphs and then what the picture looks like. So this is when n is even, this is when n is odd, and then we can also have spirals. All right, so that gives you an idea kind of what we're going to be looking at with these graphs. Okay, and then the rest of your assignment is going to be just like this, and I'm just going to let you guys explore this. You will be able to tell what all of these look like, and you'll kind of get an idea of what the 4 and the 3 mean, and you know what the shapes, the relationships to the equations and the graphs are. You can use Desmos, and you will be able to use Desmos on any quizzes or tests as well. So just go ahead and go through and figure out what these relationships are. You're going to need to match each one of these to each graph. And so, yep, I will just let you guys go through and do those on your own. And then example 9 is the same thing. All of the rose patterns, go through, see which ones of these match up, and really kind of pay attention, especially if you're going to be doing more in math later on. Really kind of pay attention to what the relationship is between, you know, this petal being on the x-axis, maybe no petals on the x or y-axis. So pay really close attention to all of those different things, the number of petals, how the petals fall. See if you can see the relationship between the equations and the graphs that you're looking at. And then also this one too. So go ahead and use Desmos, go through graph these ones, and maybe by the time you're done with these other equations, you'll kind of have a good idea of which one this is. But just go ahead and graph all of these equations on Desmos and see which one matches up to this graph. And that's all I've got for you for part 2.